Hey guys, so we are going to continue our discussion about systems of equations by elimination, but we're going to add one more step of complexity to our puzzle. I told you at the very beginning, I think that these are kind of like puzzles and that's why I like them so much, but we're going to add one more step to this. So we talked about with elimination, your goal is to have opposite coefficients. That way, whenever you add your equations together, something will eliminate. At the end of yesterday's lesson, we had some where we had to multiply by a -1. That way we made something eliminate, even though it wasn't there already. That's what we're going to be looking at today. Today's lesson is called Systems of Equations, Elimination by Multiplication. That means that we're going to have to multiply one or two equations by a constant to make something eliminate. So we're going to kind of manipulate our equations a little bit to make them do what we want to do. Okay? So let's look at our first example. If we have 4x minus 2y equals 20, and then our second equation is -8x minus 3y equals 16. Looking at these two equations, none of them are opposite coefficients. However, I notice that it would be really easy to make those two opposites of each other. If I multiplied this 4 by a 2, it would become an 8. And this one's already a -8, so that would make them opposite coefficients. So really what we're focusing on today is within that step 2, where it says if not, multiply one or both equations by a constant, their LCM, least common multiple, to make coefficients opposites. So what we're going to do right here is we are going to multiply this top equation by 2. And what that does, I'm going to kind of draw an arrow to show you this one is just turning into this next one. 8x minus 4y equals 40. So now, whenever we take a look at these two equations, I have opposite coefficients. -8 plus 8 eliminates. -3y minus 4y gives me a -7y. 16 plus 40 gives me a 56. Opposite operations to solve for y, and we get y equals -8. I can take this and I can plug it into any of my original equations. I'm going to choose to plug it in right here before I multiply by 2. It's got the most positives and it's got smaller numbers. So that's why I'm going to choose that one. When I do that, I get 4x minus 2 times -8 equals 20. -2 times -8 gives me a positive 16. So 4x plus 16 equals 20. Subtract 16 from both sides, and we get 4x equals 4. Divide by 4, and we're left with x equals 1. So the solution to this system is 1, -8. This is the one-ordered pair that makes both of these equations true. All we had to do was figure out what I can multiply one equation by so that I would have opposite coefficients. Let's look at another example. We're just adding one more step to what we've mastered over the last 2 days. So now, let's say that I have -5x minus 9y equals 15, and 2x minus 3y equals -6. Taking a look at my two equations, I can't really turn a 2 into a 5 or a 5 into a 2, so that would be kind of difficult. But let's look at my coefficients of my y's. I have a -9 and a -3. I notice that they have the same sign, so I know I'm going to need to multiply by a negative somewhere. But what can I multiply this bottom equation by to make the coefficient a positive 9? What if I multiplied it by a negative 3? What that would turn into is negative 6x plus 9y equals 18. Look at these two equations. What happens when we add them together? Negative 5x minus 6x gives me negative 11x. Negative 9y plus 9y eliminates. 15 plus 18 gives me, I'm going to cheat, a 33. We can divide both sides by negative 11, and we get x equals a negative 3. I can go and plug this negative 3 into any of these top equations that I want to. I'm going to choose to plug it right there in the middle before I multiply by that negative 3, just because it's the smaller numbers. So we're going to have 2 times negative 3 minus 3y equals a negative 6. 2 times negative 3 gives me negative 6 minus 3y equals negative 6. Add 6 to both sides. We get negative 3y equals 0. Opposite operations, divide by negative 3, and we get y equals 0. So the solution would be negative 3, 0. And that's our answer. Let's do one more whenever we just have to multiply one equation. What if I had 3x plus 6y equals 6, and then 9x minus 12y equals 18? So I see a couple different routes that we could go with this. You can say, well, I can multiply this top equation by a negative 3, and that would make this a negative 9 and a positive 9. I also notice that my y coefficients are already opposites of each other. Do you see that? How this is a positive 6 and this is a negative 12? So what if I took this top equation and multiplied it by a 2? That would turn into 6x plus 12y equals 12. So this one turned into that one. Now when I add my equations together, I get 9 plus 6 is 15x, negative 12y plus 12y eliminates, and that equals 30. Divide both sides by 15, and I get x equals 2. I can take that and plug it right back up here, and I would get 3 times 2 plus 6y equals 6. 6 plus 6y equals 6. Subtract 6 from both sides. 6y equals 0. Divide by 6 on both sides, and we get y equals 0. So our solution would be 2, 0. Remember our goal. Our goal is to have opposite coefficients. It's okay if you don't see it immediately, what you should multiply each equation by. What I keep asking myself is, how can I turn this number into that number? Or how can I make these two eliminate whenever I go to add them together? So let's bump up that complexity one more notch, where we have to multiply both equations. So whenever I'm talking about least common multiple, I'm thinking, what can I multiply both numbers by to get them to turn into the same number? So let's look at this first example. 4x plus 8y equals negative 4, and negative 5x plus 3y equals negative 21. Looking at these things, I know that I can't turn those two into the same number. I can't turn those two into the same number by multiplication. So now I have to think about, well, what can I multiply both equations by? I notice that my x coefficients are already opposites. Notice that this is a negative, that's a positive. So what's something that I could multiply each of them by to where they could turn into the same number? What's their least common multiple? Well, what would happen if I multiply this top equation by a 5 and this bottom equation by a 4? Hang with me. This top equation would turn into 20x plus 40y equals negative 20. This bottom equation would turn into negative 20x plus 12y equals negative 84. Now looking at my two equations, I can add them together to get something to eliminate. 20x minus 20x eliminates. 40y plus 12y is 52y. Negative 20 and negative 84 gives me negative 104. Divide both sides by 52 and we get y equals negative 2. I can take this and plug it into any one of my original equations. I'm going to choose the one with smallest numbers, and we get 4x plus 8 times negative 2 equals negative 4. 8 times negative 2 gives me a negative 16 equals negative 4. Add 16 to both sides, and we get 4x equals 12. Divide by 4, and we get x equals 3. So now I can write my solution as 3, negative 2. Whew. I know that was a lot of work, you guys. We're multiplying both equations to manipulate it to where something will eliminate whenever we add our equations together. Let's do one more. All right, last one. We have negative 6x minus 4y equals negative 22. And negative 4x minus 9y equals negative 2. Looking at my coefficients, none of them are opposites. None of them are the least common multiple between the two numbers. So we get to choose what we want to eliminate. So let's just say, let's multiply this top equation by a 9 and this bottom equation by a negative 4. Because remember, not only do I need them to be the same coefficient, I need them to be opposite coefficients. So I need them to have opposite signs. Notice how I'm just multiplying them by each other to find a multiple. In this case, it is going to be their least common multiple, but that will always give you a multiple, and it can work. You just may be working with a little bit larger numbers. So whenever we do that, that top equation is going to turn into 9 times negative 6 gives me a negative 54x. 9 times negative 4y gives me a negative 36y. 9 times negative 22 gives me negative 198. For my orange equation, negative 4 times negative 4 gives me a 16x. Negative 4 times negative 9 gives me a positive 36y. Negative 4 times negative 2 gives me a positive 8. whenever I add my equations together. Negative 54 plus 16 gives me a negative 38x. Negative 36 plus 36, those eliminate, equals negative 190. Divide both sides by a negative 38. And I get x equals 5. I'm going to take this and plug it back into one of my original equations. Doesn't matter which one. I'm going to get negative 4 times 5 minus 9y equals negative 2. Negative 4 times 5 is negative 20 minus 9y equals negative 2. Add 20 to both sides. We get negative 9y equals 18. Divide by negative 9, and we get y equals negative 2. So our solution is 5, negative 2. Friends, I know that this is a lot of work. I know that your hand is kind of tired from writing all that stuff. I get it. Guys, show some perseverance today. Just because they're not easy doesn't mean that they're not possible. You can do this. If you get stuck or if you get confused, please feel free to reach out to me. I would love to help you. If you have any questions, remember to slow down, show your work, check those negatives twice, and you're going to be successful today. Love you guys.